Okay, good morning all. Right, so last time we did 2024 MCQ paper for data management. So today we are going to do the other two papers. Okay, right, so that is 2023 and uh, 2022. Okay, right, so let's start with 2023. So today we can do it much faster because we have done one paper. Right, so usually the part one is not that difficult. Okay, part two is very challenging, but part one is not that challenging. Okay, right. So again, 25 MCQs, only one correct answer. The moment you see only one correct answer, then usually the exam is somewhat easier, at least less time consuming. Right. So let's move on to question number one. So let's try to do it fast as well. Which of the following statement is are true regarding inheritance in object model? Right? It's talk about inheritance. Inheritance promotes the reuse of existing type definitions. Yes. So supertype features are reused in subtypes, the non-private things. The supertype inherits all functions of the subtype. No, it's the other way. Subtype inherit from supertype. Okay. A type lattice, that is when you have multiple inheritance like this. Okay. Type lattice is created as a result of multiple inheritance. Yes. So that means 1 and 3. Right. I'll go for D. I'll go for D. Yes, answer is D. Second one. Now, if you have any questions, you need to ask because I'm doing it fast because you had enough time to do these questions. Okay. Imagine an online platform named Connect You, designed to create a dynamic community where users can discover new connections and explore common hobbies. There is need to manage huge amount of interconnected data within the network, allowing for efficient traversal of relationship. That is something like Facebook, okay? And providing friend suggestions and targeted content recommendations. Which one of the following data store is more suitable to facilitate the above requirement? Key value, graph, document, white column, relational. So obviously graph. So it's a friendship graph. Right. B. Third one. Which of the following statements are true regarding data-centric XML? Data-centric means more related to structure. Remember, XML is good for semi-structured, but it can be more towards structured or more towards unstructured, like lot of text. But data-centric means, yeah, it's semi-structured, but more towards structured. There are no structured data elements in this document. No, data-centric means, though it's XML, it's more structured. So I'll say no. These documents generally contain long-running text. Long-running text are more into the document-oriented, not data-centric. I'll say no. These documents usually have predefined schema. Yes, data-centric means predefined scheme that defines the tag names. Yes, so these tag names are predefined, like price, quantity, and so on. I'll say yes. So I'll go for C. Right, fourth one. Consider the SQL statement given below that creates student table. Student ID in primary key implicitly it is not null. This is not null. This is not null. Varchar 50, plenty of width. Date of birth, date, but not it's null allowed. Gender char 1, only one's character, but that character must be either capital M or simple F. Okay. NIC char 2L, varchar 2L, it must be unique. Right? It must be unique. Which of the following insert statements doesn't result in any constraint violation? So you need to look at the not null constraint, check constraint, Okay, and width and data types. Okay, insert into student, and of course, always you must have the primary key because this is not auto number. So always check whether you have the student ID. If student ID is not there, definitely wrong. And student ID is there, then first name, last name, date of birth, gender. First name, last name, date of birth, gender, NIC. First name, last name, date of birth, gender, NIC. It's the same thing, right? So it's same fields. Same fields. What about the first one? First name, null. So first name, not null field. So this is wrong. Second one, no null values. So this is valid. Alice Wonderland, last name. Date 1988, 11:30. Date of birth, right? So then, so why we have 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. Student ID, first name, last name, date of birth. Gender is X. So gender must be capital M or capital F. Bro. Right, next one. ID is 5, fine. First name Eva Williams. Date of birth 1985, 4/25. Right? Uh, yeah, maybe the date format is different. Maybe month and date. Yeah, that is usually, yeah, maybe they have configured to year, month, date, right? Year, month, date. Usually American, of course, it's the year, date, month, but let's see, because some you can configure it to year, month, date also. Let's see. If nothing is there, I will take this as a wrong one. F is fine. And what about this? So NIC must be
So we
Vacha
can't
12. Sorry,
we can't take C
why?
because NIC is Vacha 12. In NIC number there are 13 characters.
Yeah. All right. Okay. Let's see. So it's Vacha 12, maximum 12 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So there are 13 characters. So therefore, this is anyway wrong. Anyway wrong. So the next one, student ID is fine. First name is fine. Last name is fine. So date is definitely wrong, right? You can see this 13, 13 can't be, right? Whether it's year or month. First, I don't know whether this is here or this is here, but for any of these, 13 is wrong. So therefore, this is a invalid date because these things are validated. Okay, so this is invalid date. So this should be possible answer, but let's look at the other one. Student ID 1, first name John Doe, 1, 1 fine, male, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is fine. So that means answer is D because this is not a valid date, right? Valid date. Fourth one. Yeah. So all these are wrong. This is the only correct one. Yes. Answer is E because we are looking for the not result in constraint violation. All these violate. E is the correct one. Okay, E is the correct one. Right. Fifth one. Which one of the following concepts involved using different database technologies? Different database technologies to handle different data storage requirements within an application. Polyglot, acid, polymorphism, vertical scaling, homogeneous storage strategy. So if you use right combination of graph, key value pair, and so on, that is called polyglot persistence, right? We have discussed that. Because different technologies to handle different storage. So mostly these are used in NoSQL databases. I'll go for A. Yes. 6. Consider a computer system which contains 100 blocks. So that means you have 100 blocks. Right? 100 blocks. Remember, block is the smallest unit of read for the OS. It can't read anything smaller than a block. Unordered file record. That means it's not sorted. That means you can't do binary search. You must do linear search. Unordered. How many block need to be accessed when search criteria is satisfied by multiple records? Right? Whether it's multiple record or single record, the worst case is n because we don't know where is it, right? And it's not sorted. So therefore, worst case, there's nothing called best case. Maybe average case is n divided by 2. But because this is multiple records, you can't even say average case is n divided by 2. Right? So therefore, anyway, this doesn't say whether average case or worst case because even we can say average case as n divided by 2 because there are multiple records. So therefore, I'll go for n, which is the worst case. Right? Worst case 1000 because it's not sorted, no binary search. Yeah, answer is B. Okay. Right. Even though we can do binary search because these values might be in two different, right, different places. So therefore, even for binary search, I can't say log 2n or whatever, right? Because multiple records, like multiple record can be 1, 2, 3, or maybe 80. Right? But if it is a range query like salary between 10,000 to say 100,000 to 150,000 and you're sorted by salary, and then that is a different story. Okay. So even though the data is sorted, if you are looking for different values like Nimal and Rohan, so then again you need to do that again, another binary search or something like that. Right. So therefore, it's B. 7. Which isolation level ensures that transaction avoids lost update, dirty reads, while phantom reads? Right. So I gave you an updated note also, right? Yesterday, just use that note because I slightly make that note more readable and added few more points. Okay, minor changes, but make sure you use the new note. Okay, fine. So remember the isolation levels goes from 0, 1, 2, 3. This is serializable. Nothing happens. Right here, all the issues happens, including dirty reads. Right? So zeroth level is read uncommitted, right? Read uncommitted. This is 0. Read committed is what? Right? Read committed is 1. So next one is repeatable read. And the fourth or the third one is because we start from 0 is serializable. So there's nothing called unrepeatable read. Okay. Uh, yes, sorry. No, repeatable read, right? Yeah, unrepeatable read means there's issue. So therefore, anything but phantom issues are there means not serializable. Serializable means phantom issue is also uh, handled. So therefore, it can't be the best case. It must be one less than the best case, right? So that must be not read committed or read uncommitted or read committed. It must be repeatable read because this is one before the serializable. So that has only phantom issue. Phantom issue is resolved in serializable. Okay, I'll go for A. Yes, A. 8. Consider the relation employee given below. The primary key is underlined, that is employee ID. Which one of the following index structure is most suitable to efficiently retrieve the details of employees based on the marital status or the married or not and gender? Remember here only married or not, gender only male or female. So for this kind of where you have only few values, so the best thing is bitmap index because you can have one and zero kind of a thing for these things because both are boolean. So then true, 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 false, and so on. And then you save this as an index. So that is called bitmap index. So B plus tree is for range queries like salary. Hash index when you are looking for one values rather than set of values. Your query always or almost all the time results in one value, one record. Function based index is when your query involve something like upper, right? That kind of functions. So then you create the index already included in that. So bitmap index is creating this kind of a bitmap pen because it's a very small file. It can includes one or few fields which has only few values. Okay, right. So we'll go for D. D. I don't know what is reverse index is. Maybe you can do Google's ChatGPT or Gemini asks what is reverse index because I am not very sure. Maybe examiner is interested in this. Okay, in a future paper. Right, 9. Which of the following statement is are true regarding spanned and unspanned file? So that means records are not part of the records are not saved in a block. If it doesn't fit into a block, everything is taken to the next block. Simple question, right? Each record will be stored only one block in a span file organization, right? No, that is unspanned. Unspanned. Span means record can be fit into two blocks. But unspan means you always fit it to one block. If it is not enough, you put it to the other one rather than put it in there. So therefore, I will say no. Span file organization will be used whenever record length is larger than the block size. If the record length is larger than the block size, right, that means one record. Even one record cannot be fit into the block. That means huge records. So then, of course, you can't go for unspanned, right? Because it doesn't practically work. So then you have no other option, right? Go for span file organization. Okay, I'll say yes. Even one record doesn't fit means definitely. Or if your records are very big, maybe we have no other option going for span because otherwise it's a lot of waste. Unspanned file organization optimize the utilization of unused space. No, right? Actually, in unspanned, there are waste of space, right? If it is a small record, that waste of space is actually negligible. By storing portion of the record in one block and remaining part in another. So that is correct for unspanned. But it doesn't optimize the utilization of unused space. So therefore, partly correct, partly wrong. I'll go for B. I'll go for B. Right, 10. Right, cap theorem is related to what? Uh, Transaction handling in NoSQL databases. Remember, there are three factors. You can only control the two, not all three. Okay, cap theorem. Cap theorem is fundamental concept in distributed. Sorry. No, it's not distributed database, right? No, it's not distributed databases. It's for uh, unstructured and semi-structured data, right? Yeah. Oh, distributed. I can't remember.
So it is for distributed
It is
database.
distributed, right? Sorry. So that means what are the three factors? I think scalability,
Consistency, availability, partition.
yeah, availability, consistency. What is the other one? Tolerance, partition tolerance.
Partitioning. Partition tolerance.
Yeah, partition tolerance. So it says only two you can handle, right? Or not all three you can control. Right? Only two you can control. You can't control all three, or you can't optimize for all three. Right? Consistency, availability, yeah, partition tolerance, CAP acronym. Fundamental concept of distributed database that explains the trade-offs among the three properties: consistency, atomicity, not atomicity, right? That is not atomicity, right? That should be availability, right? So I'll say no. Second one, partition tolerance ensures that every request received by a non-failing node in the system must result in a response. Partition tolerance. Partition tolerance. You can break it into parts, right? But that is, I think, availability, right? Non-failing node system must result in no, that is more into the availability, right? I'll say no. This is availability. According to the theorem, a distributed system can prioritize at most two out of the three properties. Yes, only two you can prioritize or optimize, not all three. Right. We'll go for E. Okay. E. Sorry, C, not T, C. Yes, answer is C. We can handle only two of those. There's no way we can optimize all three. Always we need to compromise one. Right, 11. Which of the following statement is are true regarding the distributed databases? It involves collection of independent databases on non-network computers. Of course, it must be network computer, right? And mostly those are dependent. Part of the database in one node, other part, no, I will say no. I will say no. It consists of single central database file, then it is not distributed. Data items are generally stored closer to the location where they are most required. Yes. So we have different sites. If a data is mostly used by this site, we put it there, right? Rather than put it there or in a central location. Okay. Of course, shared data you need to decide. Put it into one site, which is the best for the queries. Okay. That is definitely correct. Distribution increases the complexity of the data synchronization, obviously, right? So that is the disadvantage of distributed databases because you need to synchronize data and also transaction handling, okay, backup security, so many complexities. I'll go for D. Yes, D. 12. Consider the schema given below related to employee table. Primary key is underlined and foreign keys are italicized. So this is a foreign key. Which one of the following SQL statement adds constraint where the employee age should be greater than 18 and less than 65? Okay. Create age constraint, right? Check. So this is, so it is not assertion, right? It is not assertion. It is not a trigger. But these assertions, right? So this is not an assertion, right? So it must be assertion if you are doing this check, right? This is check. Okay, let's keep it for the time being. Okay, because it's not assertion. It just say check. Okay. Create age constraint assertion. No, it must be create assertion age constraint, right? So this first use the keywords is create assertion. Let's keep that also suspicious. Right, so this looks okay. Create assertion, create assertion. Uh, you just give it a name, age constraint, age constraint, age constraint. Right, it's a check constraint. So far, so good. Right. Where the employee's age should be greater than 18 and less than 65. So that means age must be greater than 18, less than 65. So that means there should not be any records outside this. Okay, outside this. Not exists, right? Not exists. Age less than or equal to 18 and age greater than or equal to 65. Not exists. Right? That looks okay. Not exist. Anyway, where you have not exist, but this one is anyway. You don't have to look at the B, right? Right. So let's only look at C. Not exist. Select all from employee. There's no where part also. Right. So anyway, where part is also missing, right? Anyway, I will not look at this. Where part is missing. This one exists. Select all from employee E where age less than 18 or greater than 65. So if there's exists anything less than 18, no, not less than 18, right? It must be less than or equal to 18, right? Because 18 is not valid, right? 18 is not valid. So therefore it must be less than or equal to 18 or bigger than. So therefore I will not take it because the equal mark is not there, okay? So here,
So I think we don't need equal because employee age should be greater than 18 or less than 65.
so greater than 18 means this check for the invalid things, right? Invalid things. Invalid means less than
So
18.
exist, it is exist, not exist. Sorry, it consider exists.
It consider exists.
Exist.
It check whether there's exists anything lesser than 18, right? But what happens if there's an employee with age 18? That is invalid, right? According to this, 18 is invalid. But this doesn't check 18. If age is 18, this is not going to be satisfied because this is looking for exists. If exists, not allowed. Is it clear or not clear?
Yes, sir, understood.
Yeah. So therefore, this should have or must have equal mark because this exists. I will not take this. Right. So this one not exists. Right. Not exists. Not exists. It's not exists. Select all from employee where age less than or equal to 18. So that means anything less than or equal to 18 or anything bigger than or more bigger than or equal to 65. So anything here or here must not exist. Not exist. But not exist. Not exist. Sorry, not exist means anything here. If anything here is there, it's violate. Because not exist means anything here. Right? So that is correct, right? No, right? Check not exist. Not exist. Not exist means not exist here means all the record exist here. Right? If all the record exist here, that is fine, right? All right, so that is what we need, right? Check whether it's all the records are exist here, right? So that is fine, right? That is fine.
Sir,
So,
it's
yes.
confusing for me the exist and not exist part.
Sorry.
It is confusing for me. It is exist or not exist about it.
So you need to check, right? You need to check this. What you need to check? If this is violated or not, right? Check this is violated or not. Now this say you need to check whether the all the records must be less than or 18. Forget about the not. Exist means all the record must be here or here. That is exist, right? Here or here. The not exist means all the records must be here, right? Not here. So that is what we need, right? That is what we need, right? Anyway, this is anyway wrong because, so then what about this then? X is age less than 18, but there the equal mark is not there, right? Because here the issue is equal mark is not there. Because you are looking for the violation. Uh, so it must be DOE, right? I'm also now confused a little bit, but it's check and not check. Okay. Let's see the answer first. The examiner has taken E. Okay. So shall we ask ChatGPT to explain it? Because I'm also a little bit now confused after looking at this answer, exist and not exist. Okay. First, let's check the answer from with ChatGPT also. Whether ChatGPT confirm the answer. Then we will ask it to explain. Okay. Yeah, invalid is this. Remember, equal mark must be there. Correct constraint must ensure that no such invalid row exists. Yes. An assertion is usually written as check, not exists, blah, blah, blah. So we must put the violation condition inside where? Violation condition. Because we need to make sure that not exists such things, right? Not exists such things. Violation condition is less than or equal to 18 or greater than or equal to 65, right? Because it must such things not must not exist. Okay. Uh, anyway, A, yes, invalid SQL statements and so on. Okay. Yeah. ChatGPT says yes, E, right? So you need to put the, of course, you can use exist also, right? But then it must violate in the other way, right? So this not exist means violate condition. The violate condition is less than or equal to 18 or greater than or equal to 65. Okay. Shall we ask ChatGPT to write this using exist? Right? Because you can write it using exist as well. That then it must be less than or equal, less than 18, sorry, greater than 18 and less than 65. Above constraint using exist. Right, so that means greater than 18 and less than 65. Now it must be, yeah, you can, still it always use not exist, right? I rewrite, right, you can see if you want, I can also rewrite it using only exist, right? That is what I want, okay? And that is what I want. Because you can write it without not also. Right, so now you can see check exist less than no greater than no equal to 18 or less than. Now if you use exist, you must write the valid scenario, right? Valid scenario. But if your constraint use not exist, you must write the invalid scenario. Okay. I don't know why this says equal false. I don't know whether that is required. I don't think that is.
Because it's also invalid scenario.
Sorry?
It is also invalid
It is
scenario.
invalid scenario, but it says false. That is why it says false. I don't know whether you need to write like equal false, so then you should be able to write the valid scenario. Okay, shall we write it and ask whether that is okay? Okay, so let's write in the valid way and ask whether it's okay. Uh, Select all age greater than 18 and less than 65. Okay, is this correct? It says no. That means always you need to write not exist, right? Because that says it must exist. Okay. So here they write it using exist. Okay. But what they say is then use false, right? Always use false. Okay. Shall we ask that from? I don't know whether ChatGPT says always use that syntax. Uh, Shall we ask from Gemini also? Because remember, assertions are not supported by databases, right? Almost all the databases. So therefore, we can't test this also, right? None of the major databases support assertions. So therefore, this only we need to understand this in theoretical level. Assertion. So let's see whether Gemini says accept it or not. Technically, your syntax is valid. Logically, it's like not doing what you want. Okay. Yeah, it's chat. Gemini also says use not exist. Okay. Uh, right. It looks like ChatGPT, Gemini all saying use not exist, and the write the invalid scenario here. Right, not exist and write the invalid scenario here. Okay. But ChatGPT doesn't use false, right? It says less than 18 or greater than 65. But see, that is Gemini. So what about ChatGPT? ChatGPT says uh, write the invalid scenario and equal false, right? But ChatGPT says if you use exist, right, use this as false. But Gemini says use not exist. So it looks like Gemini doesn't recommend us to use exist at all, always not exist. But ChatGPT says if you are using exist, still use the same invalid scenario and say false rather than not writing the invalid scenario here. Right. So rather than writing the valid scenario here. Okay. And it's a little bit confusing. I think uh, one thing is almost all the time go for not exist. If not exist is there, right? If exist is there, right? At least again write the valid scenario. Okay. Sorry, invalid scenario. If you go for exist, write the valid scenario and say false. Okay. Because this is a theoretical thing we can't test and verify from a particular technology, right? Right. Key exam rule to remember. All rows must satisfy condition. Use exist, then say equal false, or use not exist with violation. Okay. Anyway, it's a little bit confusing for me also, right? But because this is a pure theory, right? Not practical like SQL, right? So anyway, examiner has taken E. So that means examiner has used check. Sorry, not exist, right? Not exist. So I think better thing is see whether there are not exist answers, okay? Rather than exist answers, or else see whether something like false, okay? Right, 13. Which of the following statement is true regarding consistency in NoSQL databases? Logical consistency always ensure that the same data item has the same value when read from different replicas. Logical consistency, right? Logical consistency, session consistency, eventual consistency. Okay. I'm not 100% sure about what is logical consistency. Session consistency means within the session. That means if you update, you must see the your value, updated value. Let's look at the second and third first. Okay. Session consistency in NoSQL databases ensure that within a session, the client will observe its own updates. Yes, that is definitely yes. So in my session, I must always see my updates. Maybe others may not still see it, but me, I should see my updates. Okay, always. Eventual consistency means when someone do an update, right? Of course, immediately others may not see it, but after predefined time, it must be visible to all the nodes. Okay. Is preferred though immediate consistency in NoSQL databases. Yes, in NoSQL databases, because we work with millions of users, a lot of data. That is the whole purpose of NoSQL, right? Like MongoDB. Right? So now again, let's look at what is logical consistency. Always ensure that the same data item has the same value when read from different replicas. Okay, I'm not very sure about that. Shall we look at the note because I'm not 100% sure about that. Okay, logical consistency. What is logical consistency? Right. Logical consistency ensure that different data items make sense together. Replication consistency ensure that same data item has the same value when read from different replicas. Session consistency, read your write consistency. It means once you have made update, you are guaranteed to continue seeing the update. Okay. Right. So then logical consistency is different, right? That means together it makes sense. If you are looking at two or three data, those data must be consistent with each other, right? Different data items make sense together, right? So that is not this answer, right? Always ensure that the same data item has the same value. No, when you look at some related data, it must make sense. It must be consistent. Okay, I'll say no. So then it must be D. Okay. Yes, it's D. So logical consistency means when you look at related data, it must be, it must make sense, logical. Okay. Not that everyone see the same data value. Okay. Right. 14. Consider the data file contains 40,000 records stored on a disk with block size. Okay, let's blow it. So we have blocks, 2048 byte, and we have records 40,000. This must be a typical block factor question. Okay. File records have fixed size of 80 bytes. 80 bytes. Okay. Each and are unspanned. Uh, doesn't go into multiple blocks. What is the number of blocks required to this? That is typical question, right? So first we need to calculate the BFR, block factor, number of records per block. That is block size divided by uh, size of one record. Right. I will use calculator, but of course you are not supposed to use calculator unless they allow 2048 divided by 80, 25.6. So that means only 25 records, right? 25 records. Because you need to floor it. Right, so that means one block you can have 25 records, but there are 40,000 records. So therefore, number of blocks is 40,000 divided by 25. Okay. Twenty-five 1,600 blocks. Right. Answer is C. Yes, answer is C. Okay. Right. 15. We did this kind of question, right? Because we have done second papers also. Which of the following statement is are true regarding hashing techniques? So hash will map the bigger range into a smaller range. Okay. So that range might be the block number. If you have 20 blocks, maybe your primary key goes from 1 to 1,000. Still, this map into 0 to 19, like mod 20. Okay. Hash function is applied to records hash field value and returns the address of the disk block where the record is stored. Correct. So that hash field value is the field that we use to find the block number. Mostly it's primary key. If it is primary index. Collisions occur. Yes, collisions can occur because we are mapping bigger range to the smaller range. So you need to handle collisions, separate chaining or something like that. Okay. Collisions occur when the hash field value of a record that is being inserted hashes into the address that already holds another record. Yes. Collision problems will never occur, no, in external hashing since many records can be hashed to the same bucket without generating issues. No, right? Even though collisions can happen, right? I'll say no. I'll go for 1 and 2 only. D. Yes, D. What is the difference between external hashing and internal hashing? Right. So that was explained in your note. So we have set of blocks together. Okay. Let's read it because the examiner can ask it again. So this is related to indexing, right? External. Yeah, external hashing versus internal hashing. Uh, Hashing techniques for storing database records, internal hashing, external hashing. Internal hashing, uh, folding, that means you break it into parts and mod and blah, blah, blah. Addition, no, logical such as blah, 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 apply distinct selections of hash fields. Okay, these are examples for internal hashing, okay? Let's look at the external hashing. Uh, Collision can happen, then collision resolution techniques are there, okay? Right, now we move to external hashing, okay? No, still it is internal hashing. Okay. So, all right, this is a collision resolution process. Right? Either chaining, that is like a linked list, or open addressing, right? So that means you look for nearby addresses and so on, or multiple hashing. If first hash results in a collision, then we use a second hash algorithm. Maybe the second hash algorithm doesn't results in a collision, right? Open addressing, chaining, multiple hashing. Is it clear? Right? Right. So let's take one by one because examiner can ask it again. So open addressing means if your hashing algorithm results in say 5. 5 is already occupied. Maybe 5 is occupied, 7 is occupied. Okay. Now 5 is occupied. You can't use. So then it will look at the neighbor. Maybe 6 is not occupied. Though it's your hash value doesn't result in 6. 5 is collided. So therefore you put it into 6. So that is called the program scans the subsequent locations. If 6 is also not available, then see 7. 7 is not available, then you put it in 8. Yes, it landed in 5, but now your record is in 8. So that is called open addressing. Until an unused position is discovered. Okay. So chaining means if this is occupied, you have a linked list. Right? All the collided values are linked so that when you're searching also, you not only look at this, if it is linked list, you look at until the end of the link list. That is called chaining. Okay. Right. Multiple hashing means if the first algorithm results in a collision, then you use the second algorithm, hashing algorithm. Maybe it results in a available space, so then use it. So when you're searching also, if the first algorithm doesn't give you the record, you need to check the second algorithm. Therefore, this is reading wise, this is inefficient. Because if not found in the first algorithm, always you need to look at the second algorithm. Okay, so there are pros and cons. Okay. So then external hashing, right? So you must know the difference between internal hashing and external hashing. Internal hashing, the main issue is a lot of collisions and how to handle collisions, open addressing, chaining, and multiple hashing. But if you go for external hashing, right, uh, hashing for disk files is named external. Okay, so we use buckets rather than block. Set of blocks are considered as one bucket, right? So therefore, when we have set of blocks are considered as one bucket, there's a lesser chance of uh, collision. Collision. Okay, because these are continuous, so adjacent blocks. Okay. So bucket number is converted into matching block this block address via table in the file header. Okay. So since many records will fit into bucket, can hash to the same bucket without generating issues. The collision problem is less severe. So this is the main advantage. Because we have now bigger buckets, rather than small, your unit is block, because set of blocks is consecutive blocks is your bucket. So therefore lesser chance of collision because both say block 2 and block 3 is into bucket 1. So then there are better chance of lesser collision because multiple blocks are one bucket, bigger things. Okay. Still, collision can happen, right? So then, of course, you can use chaining and other things. Okay. Or you can use overflow bucket. That is, you refer to another bucket if this is filled and so on. Okay, right. So that examiner can ask that. Okay. Right. So the answer is anyway D. 16. Consider the following SQL statement used to create the purchase table. The purchase table has reference to other relations, customer and book. Right. So this is purchase table, and this table is related to customer and book. Right. You can see customer table, book table, foreign keys. Okay. Which one of the following statement is true regarding referential constraints? So this is on delete restrict, on update cascade. So this one on update cascade, on delete set null. Okay. Right. Updating customer ID in the purchase table. So it is related to the customer table, right? Customer ID in purchase table will update the customer ID on update cascade. Yes, on update cascade. Update the customer ID in the corresponding record in the customer table. Or is it other way? It's other way, right? Not when you change customer ID in purchase table, it update the customer ID in customer table because that's a primary key. Primary key you can't change. Okay, so therefore this is written in the reverse manner. So it must be when you update the customer ID in the customer table, if there's a related record in purchase table, that customer ID will be modified. If earlier it is 2, now 3, now in here also it is 3. So therefore I will not take this because this is written in the other way. Deleting customer ID in the customer table. That is fine, right? Deleting the customer ID in customer table. Okay, so that means basically you delete that record. Will be restricted. Remember the customer, delete restrict, right? Deleting the customer ID in the customer table will be restricted if there is a corresponding record in the purchase table. That is correct. So deleting customer ID means deleting the customer record. As long as there are customer values related referring to that customer in purchase table, you can't delete that customer because this is delete restrict for customer. I'll take that. Anyway, let's look at all 5. Updating customer ID in customer table, right? On update cascade will set the customer ID to null. No, it's cascade. Deleting the book in book table. So this is book table. So deleting the book in the book table will set the null, set the value here. The purchase record will, corresponding purchase record, the book ID will be set to null. Deleting the book in the book table will restricted. No, not restricted, set null. Updating ISBN. Okay. In the book table, so this is book table, ISBN is the foreign key. So it must be cascade. Okay. Set to the default value. No, not set to the default value. It must be cascade. So therefore, I'll definitely go for B. Right, B. 17. Consider the following database schema about 3 relations: user, post, and like related to social media platform. So users, user post, and likes for the post. Okay. Related to social media platform. Primary keys are underlined and foreign keys are in italics. Okay. User table, use ID, post table, post ID. Use ID is a foreign key. And like table, like ID, use ID and post ID are the foreign keys. Okay. I don't know why use ID is there. It must be post ID mainly, but maybe additionally they have added use ID. Maybe the use ID of the person who like this, right? Not the user who write this. Right. So then of course you need use ID. That is the user who like this. Okay, who like, not who post. It should be right, like that. Right. Question. Which one of the following SQL statement create a trigger to update the like count attribute of the post relation after new like is added to the like relation? So that means first of all, you must write the trigger to the like table. Like table. Because trigger must be to the like table. But you update the post table because post table has a like count. Right? So therefore, let's first check that. After insert on like, before insert on like, right? So this must be for the uh, like table, right? Not to the post table. So this says post table. No. So this is wrong. This is on like. This is on post. Wrong. Right? And this should be usually after this, right? Because after like statement is insert is success, you must update the post statement, right? Not before. So therefore, I'll go for after. Anyway, all three are after insert. After insert. Uh, Sorry, this is not considered after insert. Okay. So all three is after insert.
So B is before.
B is before insert. Sorry. So I will not take that, but if nothing is there, I will take it. But I don't like that because you are doing the count before you successfully insert your record. Right now we have two mainly. If not, both are wrong only, I will look at the B. Okay. Right. Create trigger, update likes trigger. Okay, it's the same. For each row, begin update post, right? Update post, yeah, update post. Set like count equal like count plus one, correct? Right, update post. Where post ID is new post ID end, right? Okay, let's look at this. Update like, set like count, sorry, update like, no, not update like, update post, right? The trigger is on like, but you need to update the post. So therefore, this is also wrong. Right, now let's look at this one again. Update post, set like count equal like count plus one, where post ID is new post ID end. Correct, right? New post ID. Is it new post ID? Because this insert is on like. Okay.
But new contain the a new post ID, right? So it must be.
But this is not a post, right? This is when someone do a like. This trigger operates when someone do a like. Okay. But like table also has post ID, right? Yeah. Because like table also has post ID, therefore that is fine. Okay. Yeah. So therefore that should be fine. Though we are doing the insert for post ID, but anyway, post ID must be there, right? Yes. So therefore, anyway, I'll go for A. Right. Anyway, I'll go for A. So what is the answer? Yes, A. Right. So because this is fine because post ID is in like table as well. Okay. Right. So that is 17. Right. So we'll do the rest of the stuff after the break because it's now 9:05. Right. Right. So 9:05 will start at 9:25. Right, so let's move on to question number 18 and 19. Those are related questions. The student file has 50,000 student records stored on a disk with block size. Okay, so let's blow it. Right, so let's draw it. So these are the blocks. Student file has 50,000 records. Like 50,000. Stored in a disk with block size 8,191. 8,192. Sorry, 92. File records are on fixed size and unspanned. Each record is 200 byte. 200 byte. Student records are ordered on the key field. That is primary key. Student ID. Suppose the single level primary index is created on the key field student ID and each index entry is, so let's draw the index file now. It also has the same block size 8,192, but the record is index entry 80 bytes, key field. Student records are ordered on the key field student ID. Suppose single level index entry is created on the key field ID and each index entry is student ID and each index entry. That means the total length, right? Student ID and index entry is 80 byte long. So that means this is 80 byte. What is the number of block access required to perform the binary search on the data file without using any index structure? So that means without using index structure, you use only the data file. But data file is now ordered. So therefore, you can do binary search on that data file, which is not the best way, but that will make it a little bit faster, right? Right, so let's see how many blocks we need. A block factor is number of records in a block in data file. Block size is 8,192 divided by 201 record. Okay, so let's divide it. 8,192 divided by 200, 40.9, right? 40.9. This is number of records per block. So you can't have 0.9. So therefore you need to floor it. So therefore it will be 40, right? It will be 40 records per block. Right. So that means now how many blocks? Number of blocks. Blocks. That is one block you can have 40, but you have 50,000 records. So that is 50,000 divided by number of records in a block. Right? 50,000 divided by 40. 1,250. 1,250. So 1,250 block means you can do a binary search with if you don't have the index file. That is the maximum number of block access for any search is log 2,250. Answer is C. Okay, answer is C. Yes, C. Okay. 19. What is the number of block access required to perform the binary search on index file? Now we are into the index file. Remember here we can assume one record per block. sparse index. Okay, so 1250 index blocks means 1250 records. Right, 1250 records. And what is the block factor here? For the index file, primary index file, number of records per block. Block size is 8192 divided by 80. One record is 80. And of course, you need to do flooring because you can't have half. Right? So that is 8192 8192 divide by 80 102.4 102.4 means 102 records per block. So that means how many blocks we need for the index file? That is 1250 records divided by 102. Right? So that is number of blocks. Right? If you get 12.1, it must be 13, right? So therefore you need to seal it. Number of records, number of blocks. So 1250 divided by 102. 12.25 means you need 13 blocks. 13 blocks. Right. So now we can do a binary search here. So therefore it is worst case is log 213. But you need to go up. So the 2, 4, 2 to the power 1 is 2, 4, 8, 16. So the next bigger value is 16. 1, 2, 3, 4, 2 to the power 4. So that means this is 4. So in the index file, we need to do maximum 4 block search. 4. Because it says on the index file. Plus 1 is if you access the data. Okay. So what is the number of block access required to perform the binary search on the index file? So therefore log 230. Right, log 230. B. Okay. Now you must be pretty comfortable with these questions, right? These questions must be nothing. Okay, if you know your subject. Right. So that is answer is B. Right. So let's move to the 20th question. Right, 20th question. Which one of the following statements is false regarding the replication in NoSQL databases? Replication. Right, which one is false? All the replicas have equal weight and are responsible for processing updates in peer-to-peer applications. Right? If it is peer-to-peer, all the replicas have equal weight, are responsible to processing updates, because in peer-to-peer, update can be done to any of these, right? There's no master. In master slave only, you update the master and master need to push it into the slaves. Right? You do update to the master, but read only slaves. But in peer-to-peer, you can do both insert, update and retrieve from any peer. Peer means same level, right? So therefore, this is sort of a correct, right? Updates in peer-to-peer application, right? Because updates can be done to any peer. There's no central. So peer need to propagate it to the relevant other peers. Right? You're looking for the false. If the master fails, okay, so this is the master-slave approach. If the master fails, slaves can be appointed as the new master manually or automatically in the master-slave replication. Yes, because master-slave replication, master is a single point of failure. because you can do update only to the master. So therefore, if master is failed, either everything is failed or you must promote one of the slave as the new master for continuity. Otherwise, your entire system is down. So it's correct, right? So this is the way to prevent entire system failure. Master slave replication is suitable for read intensive systems. Correct, because in master slave, we have the master and slaves. So always you do the reading from the slaves, right? And master's task is when you are there's update, push it. But this take time. That is why we say when you don't have frequent update, this is good. Right? This is good. When you have frequent update, best thing is peer-to-peer because the updates takes time to propagate. Okay, so I say yes. The master is responsible for handling read request. No, okay, read request. While because master is for the updates. While the slaves are designated to handle write. No, that is definitely wrong. No. Okay. Let's look at the also. Read write inconsistencies can occur in peer to peer. Yes, because maybe it's propagate to some peers but not to all. Right? Peer can't do it in a very consistent manner like master. Master can do it. At the same time, it push it. But peers are same level things, so therefore there can be inconsistencies. But when someone read from peer, you always get the latest. Here, sometimes you write something and you read it, your data is also not updated. Okay? So read-write inconsistencies can occur in peer-to-peer replication due to slow synchronization of data. Right? Read-write inconsistency means you read. Actually, it must be write read or for anyway. If you write, always you get your value in peer-to-peer. Right? In peer-to-peer, whatever you write, you can read because you are writing to the same peer. But here you write to the master and read from slave. That is where inconsistencies. Okay, but this says peer-to-peer. No, inconsistencies happens in read-write inconsistency, or actually it's write-read inconsistency happens in master-slave, not peer-to-peer. Okay. Uh, so I'd say read-write inconsistencies can occur in peer-to-peer replication, but slow in synchronization of data. It's now we have two wrong answers then, right? Read-write inconsistencies. So if you write, always you get the correct one because you write and read from the same node. Uh, can occur, but read-write inconsistency can occur if two different people. So you write and someone reads. Okay. But that can happen in master slave also, but there's a better consistency because it can synchronize all these nodes will get the updated value at the same time, though there will be a delay. But here there will be some inconsistencies because peer pushing to this versus that. Okay, because this one is not a master. Right? ඒක හරියට කට කතාවක් පැතිරෙනවා වගේ. කට කතාවක් පැතිරෙනකොට X ට ගිහිල්ලා සමහරට Y ට ගිහිල්ලා නැහැ. මේක හරියට ප්‍රවෘත්ති නිවේදනයක් නිකුත් කරනවා වගේ. ඔක්කොම අයට එක වෙලාවේ නිවේදනය නිකුත් කරනවා. So therefore, in a way, this is little bit okay also, right? Read write inconsistency කියන්නේ මෙයාට ගිහිල්ලා නැහැ. මොකද මේක නිකන් කට කතාවක් වගේ peers ලා අතර යන්නේ. But this is more organized when you publishing. So therefore, out of these two, because we have only one answer, I think this we may accept it as well. Okay, we may accept it as well, but therefore this is the more comfortably the false value. Right. So no doubt about this. So this is a little bit doubtful the way you look at it. Whether you read and write or you write and someone else read. So if you write and someone else read, of course, this is uh, the inconsistency can be there in peer-to-peer. Okay, so therefore I'll go for D because D is there's no doubt or no debate at all. This is a little bit debatable, the way you look at it. Okay. So 20, I'll go for D then. Yes, D. Okay. 21. Consider the patient schema given below. Note that primary key is underlined. Patient relation is horizontally fragmented, right? Horizontally fragmented in a way that patient age values less than 30 are separated from patients with age values greater than or equal to 35. It's basically horizontal partition, where condition. Right? Patient name, address, content name, this is the field we use for where condition. Which one of the following fragmentation condition is suitable to reconstruct the original relation from the fragment? So you need to do, remember if it is horizontal fragmentation, you need to do union. If it is vertical fragmentation, you need to do join. Okay? So therefore, definitely not joins. So I will get out of joins. Right? So this is greater than 30 and less than 30. Then what happened to 30? Right? What happened to 30? Therefore, this is wrong. So this is less than 30. This is also greater than 30, right? So then what happened to 30? So this is less than 30. This is greater than or equal to 30, right? Greater than or equal to 30. Answer is C. Answer is C. Okay. 22. Consider the product table given below related to an electronic shop. Note that primary key is underlined. The database administrator wanted the product table to be fragmented based on following rules. Fragment the product relation into two sub-relations so that supplier information will be stored in supplier info table and product details are in product info. That is a vertical fragmentation. Fragment the product relation, right? Product relation into two sub-relations, product mobile and product laptop. Okay. So you can see mobile phones, laptop. That should be a horizontal fragmentation based on the distinct categories of mobile phones and laptops. Yes. So that is a horizontal fragmentation. Which one of the following relational algebra expression is used to represent the vertical fragment of the above scenario? Now we are only interested in vertical fragment. Okay. So therefore it can't be sigma, it must be phi. So therefore I will not take this, because those are sigma. And those are sigma. Then we have two answers. 5, 5, 5, 5. So this is category. No, vertical fragmentation must be based on fields, right? Not category. So now I just need to check whether B is correct. Product ID, supplier name, supplier address. That is supplier info, correct? Then product ID must, remember the primary key must be duplicated. Product name, category, price. So those are the product info, right? So see whether all are use supplier name, supplier address, product ID, product name, price. Where is category? Yeah, category is also there. So I'll go for B. Right, I'll go for B. This is 22. B. Yes. Okay. 23. If you have any questions, you need to ask. Now we are into the transaction questions. Consider the following 5 schedules based on 3 transaction T1, T2, and T3 using read and write operations on the data items X and Y. Note that each RIWI, that is read, write, commit, abort, denotes blah, blah, blah. What is the non-recoverable schedule, right? Non-recoverable schedule means there's a dirty read and that first transaction writes something, second transaction read it, and second transaction commit. Now, if first transaction is rollback or aborted, nothing, you can't do anything because second one is already committed. So that is called a non-recoverable schedule. Okay, non-recoverable schedule. So it's all about your commit sequence. Right. So let's write this in a proper way. Uh, so read to second transaction, read second transaction, read first transaction, right? Okay, let's write it in a proper way. Uh, this is T2, okay? T2, T1. Okay, let's take it somewhere here. T1, T2, T1, T2. Read X, read Y, write Y, write X, commit.
So
Yes.
non-recoverable schedule have to be contained about, right? So we can consider only the statement which contain about.
Yeah, but the thing is, sometimes you just write it as commit, but actually happens abort, right? So therefore, so examiner some because we don't do abort, right? So we try to do it as a commit, but as a reality, your commit become abort, right? So therefore, I will not always rely on seeing the abort only, uh, because in final year papers they never use the word abort. So their schedules, they always use commit only, but that commit, though we say commit, it can be abort. Okay. So therefore, I will not 100% relying on the letter abort. Okay. Uh, but I don't know whether the semester three examiner, because semester three I have seen this A, right? A. Maybe examiner things consider abort as explicit thing. Okay. But anyway, I'll double check all five. This is write to X, then commit to, then read X, write X, and commit. Okay, commit. So this is dirty read, right? Read X, which is no, yeah, written by this, right? Written by this. So then, but this one already committed. This one already committed. So therefore, that is fine. Anyway, this is like a sequential transaction. So after T2, T1 happens. So there's no issue like that, right? In a serial, sorry, it's not sequential, serial schedule, there's no issue, right? This is serial scheduled. T2 commit, then T1. So I don't see any issue here. Okay, I don't see any issue here. What about this? Uh, read X, write X, write X, read Y, then read X, second one, write X, write Y, then C1, then C2. Right. So do we have dirty reads? So this is right, this is red. So that is dirty read. But you can see this is committed and then this is committed. So therefore no issue, because you commit your transaction where you do dirty read only after this transaction is committed. Okay. So there's no issue at all. Okay. There's no issue at all. C. Read X, read X, write X, second one read X, second one read, sorry, first one read Y, first one write Y, then second one write X, then abort one, abort two, abort and abort. Again, this is read X, this is dirty read. but there's no dirty read here. So the dirty read is done by second one, but second one abort after first one. Yes, when first one abort, second one can be aborted because you are doing it later. So this is fine, right? This is fine because first one abort and now second one is also abort, right? So because dirty read one must be aborted or committed last after first one. Okay. So then if this abort, this one also you can abort. If this is commit, this one also you can commit. Right? I'm happy with this one also. Right. D. Read decks. First one read. Uh, First one write. First one read Y. Then second one read X. That is dirty read. Write 2X. Then first one write Y. Right. First one write Y. And then C2. Second one commit. And now first one abort. Now remember there's a dirty read. And dirty read is done by second one and it has already committed. Now when this abort is too late, right? So now this abort means this is wrong, this is rolled reverse. But that reverse value, dirty value, this guy has read it and committed. So therefore this is definitely irrecoverable. This is not recoverable. Okay.
Sir, I didn't understand abort.
Abort means that this transaction is cancelled. That is what is the literal meaning of abort.
Okay.
So that means all these are reverse. These right values are reverse. But this right value, this guy has already used. Right? But this guy has committed first. So this is something like this. Right? Say in the class, there are two students. Right? So say this is me. Say I don't have any money. So one student says, I lost my purse. So I need some money. Otherwise, I can't go home. Right? So that means this guy needs some money. So assume I don't have any money. But the other student is there. So other student will say, okay, I can give it. I have extra money. So then I borrow some money from this guy to this guy. Now assume now this guy go home, right? But after this guy leave, this guy says, no, I need that money. Now what can I do? Because I have given that money to this guy, right? So that is cannot recover. But if I borrow money from this, if I let money borrowed from this guy to this guy, and if this guy go home first, that means this guy is not going to come back, right? So then this guy go home. So then it's safe because if this guy come back, still this guy is there, so that I can ask to give that money back. Okay, so in order to prevent conflict, if money is given from this guy to this guy, make sure this guy go home first and then this guy go home. Because otherwise this guy go home and this guy again asks, I need money. So then how can I give money? Because this guy has already vanished. So similar thing. Okay, similar thing. So therefore D is correct. Okay, so let's see E also. Read decks, write text, and commit. So that is like serial schedule. Read, write, commit. So that's like serial schedule, right? So serial schedules are always okay. So the answer must be D. Right? D. Yes, D. Okay. Right, 24. But that point is also somewhat valid because if all are commit, usually it should not be issue as well. But if you don't find any wrong answer which is related to abort, then see whether there is a possibility of commit, but though we write it as a commit, it may ended up as a rollback. Okay. So therefore, if you want to find a quick answer, maybe yes, you can only concentrate on abort things. But if you can't find an answer from those, then again you need to look at the commit commit sequence also, because though we say commit, in reality it may be aborted. Okay, so schedule is created to thinking that it is committed, but in reality it can be aborted. Okay, right. 24. Consider the following scenario: schedule S1, which consists of three transactions T1, T2, T3, and data items X, Y, Z. Note that each RI, WI denotes read and write, blah, blah, blah. Which of the following, right? So we just need to draw the precedence graph, okay? Right, I will write it as layered approach. Read DEX, read DEX, transaction 2. Transaction 2, write text, because then it's very easy. Transaction 3, read DZ. Transaction 3, read Y. Transaction 2, read Y. Transaction 2, read DZ. Transaction 3, write DZ. Transaction 1, read Y. Transaction 1, write Y. Right, write Y. Right, read is not an issue. Read write is possible conflict. Read write. That is T1 to T2. He said first time, Y read, write read issue. X, sorry. No, this is Y, first time. No issue. No issue here. Because this is the first time we access Y. This is read, no issue. This is read, no issue. Read, they said, read, they said. And this is write, they said. Right? So this is read, write. Read, write, 2 to 3. Okay? Because this is write, is it? Write 3 is it. So then read Y, no issue, because this is read, right? Read is no issue. And then write Y. Write Y means read Y and write Y, there's a conflict. Read, write. That is T3 to T2. T3 to T2. Okay. Do we have anything else? This is XX. Because no such answer, right? Let's see whether there's another one. Read, no issue. Read, write. T1 to T2 we have shown. This is Z first time, Y first time. Read Y, read, no issue. Read Z, no issue. Read DZ, write DZ, definitely 2 to 3. Then read Y, no issue. Then write Y. So that is read Y and write Y. T3 to T2. Do you have any other thing? Anyone? Because there's no such answer, right? Or did I miss anything? Read Dex. Second one, read Dex. Second one, write Y. Third one, read DZ. Third one, read Y. Second one, read Y. Second one, read DZ. Third one, read DZ. Third one, read DZ, right? Sorry, third one, write DZ, correct? First one, read Y. First one, write Y.
So it's read one by.
Sorry?
Uh,
Which
so the
one?
last one is read transaction 1.
Yes, that is my mistake. Yes. So this one must be read Y. First transaction, right? Not the last, second one. Yeah, so this is read Y and then write Y. Write Y. So that means, so anyway, we have T1 to T2, T2 to T3, then read Y and write Y. So therefore, there's T2 to T1, T2 to T1. Okay, so then there's a read Y and write Y. So that means T3 to T1, T3 to T1. Right, 1. So there's nothing called, so therefore, let's draw it again. So we have T1 to T2, right? T1 to T2. So then we have T3 to T1, T3 to T1. Then T2 to T1, T2 to T1. Then we have T2 to T3, T2 to T3. So there's nothing like this, right? So do we have this? This is T1 and T2, T2 to T3, T3 to T1. Answer must be A, right? Answer must be A. Yes, answer is A. Okay. So the early mistake was I took this as second one, but those are for the first one, right? Yeah. So the answer is A. By the way, is it serial? Complete serializable? No, right? Because this is basically a cycle. And everywhere cycle. This is a cycle, this is a big cycle. So this is definitely not complete serializable. Okay. Because there are cycles. Right. Last question. Consider the schedule provided below, which involves two transactions T1 and T2. The initial value of A and B are 10,000 and 2,000. Right, so let's mark it. Consider the schedule provided below, blah, 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 T1 and T2. Initial values of A and B are, right, A is 1,000 and B is 2,000. Respectively, what are the potential values of the variable sum after executing write sum operation in T2? That is this, right? T2 taking into account that the transaction T2 is executed under two isolation level, uh, read uncommitted, right? 2 means 0, 1, 2, right? Read, sorry, under two isolation levels, read uncommitted. So that means uh, you read uncommitted values. Sorry, two. Read uncommitted, then serializable. Right? Serializable means all the issues are prevented. Okay. Read uncommitted means level 0. All possible issues can happen. Okay. Right. So this is a tough question. Right. So let's assume it's read uncommitted. That means you don't care anything. Any issue can happen, right? Any issue can happen. So it doesn't prevent any issue. Okay. So if it is read uncommitted, the second level 0 is read uncommitted, level 1 is read committed. Right. Right. So therefore, this is read day is 1,000, read B is 2,000. Now A is multiplied by 2. Now A is uh, 2,000 and you write it. So this will just happen as it is, right? Now no checks. Now A is 2,000. Okay. 2,000. Because, sorry, yeah, 1,000 into 2, 2,000. Now both A and B are 2,000. Now this guy read A, which is 2,000. Read B, which is again 2,000. Then do the sum, which is 4,000. Okay, so therefore this will write 4,000 as sum. Sum is 4,000. Now this guy multiply B by 2, which it has read here, right? Because you don't read it again. So it has read B as 2,000. 2,000 into 2 is 4,000. And that 4,000 is written, right? That 4,000 is written. And commit. Okay, commit. So then read A, which is 2000, read B, which is 4000. So therefore A plus B is 6000 and sum will be 6000. Okay. Right sum is happening 2 times. Okay. What is the potential value of the variable sum after executing each right sum? Each right sum. So here it is 6000, right? So therefore first time 4000, the second time 6000 if it is read uncommitted for me 4600,000. Right, 4000, 6000 is in this answer and this answer. Other answers it's different, right? So therefore I'll isolate into E and D now. Now we'll need to look at serializable. Right, serializable. So serializable means no read uncommitted values. Okay, that means you are read committed. Only you read committed values, and also you make sure repeatable reads also. Right, repeatable reads also with and also phantom. Of course, there's no phantom issues here. Okay, right. So now let's do it like that. It's anyway. This is a very fussy one for me also. I'm also not 100% sure, but I'm just going by my theory that I have understood. Okay. Right. So again, let's start it as 1000 and 2000. 2000. So read day 1000, read B 2000, then 2000 into 2 is 4000. So therefore now A is 4000.
So it has to be 2000.
Sorry? Sorry,
Has
1000
to be
into, yeah,
2000.
yeah, 1000 into 2 is 2000. Sorry. So therefore now A is 2000. Right? Not B. A is 2000 because we multiply A by 2. Sorry for that. Right. So now read day. Now you are not supposed to read uncommitted values. This is uncommitted. Right. So remember, serializable means read uncommitted plus repeatable read plus phantom issue is prevented. Okay. So therefore it won't read the uncommitted value. Right. So actually it should wait for the commit. Right. It can't read the current value also. It needs actually this will wait until this commit. Right? So this read must wait until this commit. Okay, because this is not yet committed. So therefore, I will wait this until this is done because that is called read committed. Right? Because serializable is read committed plus non-repeatable read. Right? So therefore, I will delay this. Actually, this is what happens in locking mechanisms also. So then this will happen. B into B plus 2. Of course, this is not happen means any of the subsequent can't happen because it must be happening in the same sequence. So then it will do this one. B is B into 2. That is B is 2000. 2000 into 2 is 4000. So your new B is 4000. Now this is still waiting. And commit. Now transaction 1 is over. Now of course it's like a serial now happens. Okay. So now read day, which is the committed value. Committed value is 2000. Committed value of B is 4000. 4000 plus 2000 is 6000. So therefore sum will be 6000. Okay, 6000. So then again read day, which is again 2000, and read B, which is 4000, and do the sum, which is 6000, and write. So that is repeatable read. When you read the same value twice, you must read the same value, right? Repeatable read. So repeatable read is also done, right? In serializable, because repeatable read is level 3, level 2. Serializable means level 2 plus no phantom issues. So I'll go for 6,000, 6,000. Okay. Uh, so, but there's no 6,000, 6,000 anywhere, right? Why is that? So 2,000, 4,000. Sorry,
Because
sorry, sorry. This happens after this, right? So therefore, V is 4,000, right? No, V is 4,000. A is 2,000.
so it took it as a fresh value. A is 1000 and E is 2000.
Why?
I don't know why, but the answer is given like that. But
Oh,
according to the logic, your one is correct.
yes. So that means it has take the fresh value. Yeah, that is another possibility because then there's no inconsistency, right? There's no inconsistency. Uh, but then this value is not considered, right? Yeah, so that is anyway, that is the second possibility. You don't delay it, rather you read the uncommitted value, sorry, committed values up to this point. So up to this point, this is not committed. So therefore, up to this point, committed value is 1,000 and 2,000. Maybe, yeah, that is another possible way, but I don't know whether that do it like that. Yeah, maybe that is the other option, right? So rather than you delay it, you read the currently committed value, which is 1,000 and 2,000, right? So then this is 1,000, this is 2,000, then this is 3,000, then this is 3,000, uh, then commit. So then do they use the new value? Because this is now committed.
Yes, I used a new value.
Yeah, so because now it is committed, maybe now it read it as a committed value, which is 2,000 and 4,000, which is 6,000. So then you write it as 6,000. Okay. But then it violates repeatable read, right? Because here you read 2,000, sorry, here you read 1,000, here you read 4,000. Same value when you read twice, you get two different values. So how can you have that kind of a scenario when you are in serializable? Remember, serializable means there should not be any non-repeatable reads. But here, same value read twice, two different values. So therefore, I'm not happy with this answer. But if you go by that, it will be 3,600, 6,000. Then the answer will be E. Is that the answer? Yeah, answer is C. Right. I want to put this into the chat GPT as well. Okay, chat GPT as well, because I'm a little bit confused with examiner's approach. Because my approach is slightly different. Right. You wait until this is committed. Okay. Anyway, let's see whether, by the way, my answer is not there. Okay. Uh, my answer was actually, what was my answer? 6,000, 6,000, right? Yeah, 6,000, 6,000. That is 4,000, 6,000. Actually, my answer was 4,000, 6,000. 6,000. Other one, 6,000, 6,000. Okay, 6,000, 6,000. Okay, shall we put it into chat GPT as well? I prefer, because my answer is not in the answer sheet. Anyway, let's put it as MCQ, right? Okay, let's put it as MCQ. Anyway, this is a little bit tough one for
Sir,
ChatGPT as well. Yes.
don't give him the potential answers because he can bias towards the answers.
Yeah, that is what I also thought of. Can the ChatGPT understand the question? Read, yeah, it should be able to understand the question, right? Yes. So let's not give the answer. So that is a better thing. Okay, let's go slowly and track the values step by step. Okay, I'm just looking for the final answer. Oh, 4,000, 6,000, 6,3. Oh, is that same as answer sheet?
Yes, sir.
Yes, right. So 4,000, 6,000, 3,000, 6,000. Okay, I think, okay, let's look at the explanation. Anyway, we have no issue with the serializable one, right? Transaction one, right? Say under read, yeah, the issue is under serializable, right? Yes. Read uncommitted, we have no issue. Right now, let's move to serializable. T2C is only committed data. Committed data. Execution is equivalent to some serial order. Cannot see right day. It's only see the original value. Second write after T1 commits. 2004. Yes. So it has not delayed the operation, rather it has read the currently uncommitted value, right? Yes. Currently uncommitted value. Right. Okay.
Sir, but it contain non-repeatable conflict
Yeah,
in
that
serializable.
shall we ask that? That is my concern also. But your result, your approach for serializable results in non-repeatable reads, isn't it? We'll put some pressure. See whether it has a logical. Uh, let's clear this up properly because it's very common confusion. Okay. Short answer, yes. If we strictly apply serializable, T2 must not see two different values. So it's basically agree with my argument. So my earlier serializable explanation needs refinement. Thank you. Okay. So now it says it's going to change it, right? Thank you for questioning it. What serializable really means, just no dirty reads. Okay. It's not just no dirty reads. It's more than that. That is what our argument is. So serializable means the effect must be equivalent to some serial order T1 and T2. So T2 must behave as if earlier T1 runs completely before T2. So, okay, so that is what our argument, right? We delay that until T1 happens, okay? Or T2 runs completely before T1. So non-repeatable reads are not allowed. Seeing old value first and new values later is not allowed, okay? So therefore now it has recalculated it and now it says both must be 6,000, okay? Uh, So now it says, uh, but now it's but now it's again 3,000, 6,000, right? So that is not my answer anyway. So my answer is 6,000, 6,000. So it has accepted it, but it has done the calculation in a weird manner again. Then T2 run, sum is 6,000, 6,000. Second time 6,000, first time 3,000.
So I
Anyway,
think he's
that is again the
mistakenly
final
rewrite it again.
UCSC answer, right?
So I think ChatGPT again made a mistake, I think.
I hope so. Right? Because it accepted the argument, but again, I think it's going by its old fashion. We can ask double check, or we can ask isn't uh, final answer under serializable 6,000, 6,000. But this is a bad way of influencing. I will ask, can you double check? Okay, it's now double checking. So it says key rules we non-negotiable. Uh, right. What cannot happens under serializable, two different values. So why your doubt is valid? Okay. Now it says yes. Ultimately, right? After pushing, 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 I don't know. It's because of the pressure. Now it says serializable either 3,000, 3,000 or 6,000, 6,000 because otherwise it's non-repeatable read. Okay. Uh, so under serializable, T2 will write either 3,000 twice or 6,000 twice. So that is fine. Okay. That is fine. So it says you are 100% right to question this. That's exactly how examiners try to trick students. Okay. So So at least we can be proud of that. Now, a lot of people says AI is going to replace our jobs, right? So how can AI replace our jobs? We can challenge AI and find that AI is not perfect, right? Right. So yeah. So at least ChatGPT agree. But if you get this kind of a thing, maybe in your exams, make sure you give your feedback to the examiner, right? Now these days you can even tell give these links as your proof. Now remember when you say they ask you to give the feedback because until they that deadline they don't start marking. So now you can, if you get this kind of a question, you can say my answer is this because of this reason, and ChatGPT also confirm that. And this is the link. You can just share the link with the examiner, right? That is not offensive thing, right? That is because this is not school education. This is university education. You can always argue. You can challenge your lecturers, right? In intellectual level, right? So that's it. Okay. Final one is debatable one. Okay. Right. So that's it. 2023 paper. Okay. Right. So we'll take 15-minute break and move on to. No, I don't think the semester 4 is postponed, right? Actually, what will happen is semester 4 will be shrink, right? Shrink because otherwise semester 1 students will have extended time, right? Okay, semester 4 will be shrink rather than semester 4 is postponed. This should be due to some practical issue, right? Otherwise, because it's only 1 week, right? They have postponed. Right. So we'll start at 10:45. Right, 10:45. And that will be our last paper, okay? Okay, so let's continue. Now we move on to 2022 paper. And this one, you can see multiple answers are possible. Okay, one or more correct answer, negative marks applied. So therefore, be very careful. You need to be very careful, and you usually take more time as well. Because just because you can find the answer, you can't just skip it. Other questions, other answers. Okay, right. So let's take one by one. Which one of the following is are true regarding object database concepts? Right, object database concepts. A. Typical components of objects are state and behaviors. That is correct. And that is correct. Object cannot possess specific operations defined by programmer. No, object can have operations, right? It says cannot. No. Transient objects, that is not persistent. In an object-oriented programming language, exist only during the program execution. Yes, because it's not persistent, like a control object. Okay. View object. An object-oriented database can extend the existence of an object and be stored permanently in the database. Yes, so then it's persistent object, not a transient. Last one. Persistent objects in an object-oriented database cannot be shared by other programs. Of course, it can be shared because you save it to the database and other system access the database. That is data sharing. So I'll say no. I'll go for A, C, and D. Right? A, C, and D. Yes, A, C, and D. Second one. Which of the following statements are true regarding below given type hierarchy? Right? Person, employee, undergraduate. Type hierarchy. Right. So person must be the general class, employee and undergraduate must be the subtypes. Okay. Right. Age can be implemented. Now let's see. Name, address, NIC, birth date, age. Name, address, NIC, birth date, that is inherited. And then salary and appointment date. Here name, address, NIC, birth date, age, course name, academic year. Actually, you don't need age because age can be a derived attribute, right? Derived attribute. Age can be implemented as an operation that calculate the age using the attribute birth date and current date. Obviously, yes. So you don't need to persist age. But age can be attribute, yes, but you don't need to persist it. Right, second one. Employee can be defined as employee, subtype of person, yes. Name, address, NIC, birth date, age, salary, appointment date. No, you don't need to mention name, address, NIC, right? Because those are from person. You just say employee subtype of person and then you can say salary appointment date. That's it. Because other things are inherited. Because you must have already defined a person. So no need to define this. I'll say no. C. Undergraduate can be defined as undergraduate subtype of person, course name, academic year. Yes. So you just need to specify the new attributes. Undergraduate can be defined as undergraduate subtype of employee. Not undergraduate is not a subtype of employee. Okay, it's a subtype of person. The subtype includes only the additional functions that are specified to itself, not only additional functions, additional attributes. So it says only additional functions. So we'll go for B and C. Sorry, A and C, not B and C, A and C, correct. Okay. Third one. What is the most suitable database model for the below e-commerce website? The shopping cart කියනකොට ගොඩක් අයට යන්නේ මොකද්ද? Key value තමයි. හරි? That is example given in your note as well. Shopping cart on the e-commerce website records data pertaining to individual shopping sessions. Normally, customer who visited the website fill their shopping cart and later change their mind about buying the selected items more than those who proceeded items more than those. What is that? Their shopping carts and later change their minds about buying the selected items more than those who proceed to pay. Okay. Usually there is a sharp increase in sales and thereby traffic on the website during the peak seasons around holidays or during sales and special promotions. The shopping cart should quickly record and get the data simultaneously while ensuring that no item from the cart get lost. Right. So object-oriented key value, column family, graph database, relational database. Remember, this is shopping carts are often actually in UCSC note also they say just use key value pairs, right? Uh, Third one, of course, if you want, you can go for relational database or object-oriented, but in order to get that flexibility, because these items can be frequently changed and different type of items and blah blah blah, we need bit of flexibility, so key value will be better. Okay. Yes, answer is B. Okay, answer is B. Fourth one. Which of the following statement, remember you need to do the first questions fast because the last set of questions take more time, right? Transaction handling and so on. And there are calculations at later. So therefore don't relax, do super fast because this is definitely a paper where the time is super important because of the calculations. Remember for the both papers, we have 2 hours, right? Structured essay and MCQ. I don't know whether they give both papers, right, together or whether they give first paper and after first hour only they give the second paper. But if they give both first paper and second paper, try to finish your first paper quickly and start second paper early, right? If they give you second paper, because remember second paper is very tough. Second paper is very, very, very tough, okay? And time consuming. And first paper also, there are some questions at the latter part. So therefore, don't relax when we are doing these first few questions, okay? Which of the following statements these are true regarding structured, semi-structured, and unstructured data? Structured data are represented in a strict format defined by database schema. Yes. Right, yes. Semi-structured data has an identical structure. No, identical structure means structured, not semi-structured. Semi-structured data can be represented based on a tree graph data structures. Here, tree graph, key values, those are good for semi-structured. Unstructured data is a mix of schema information with data values. No, then it's more semi-structured, right? Unstructured means hardly any structure. Structured data has limited indication of the type of data. No, structured data has a very clear indication of what is the data type because it's structured. Right. I'll go for A and C. A and C. Which of the following statement is are true true for the object identifier, that is like your primary key in object databases. OID is a non-immutable. So object ID must be immutable. Mutable means can be changed. Right? It must be immutable, but non-immutable means again telling mutable. Right? So it must be immutable. I'll say wrong. This is double negation. Okay. B. OID doesn't depend on any attribute value of the object. Yes, it must not depend on any other attribute, right? It must be unique identifier. Okay. Yes, it must not depend on any other attributes. Remember the dependencies, right? Partial dependency and so on about normalization, transition dependency, blah, blah, blah. So your independent guy is the OID or the primary key. OID of a deleted object can be assigned to a new object in the future. No. So that is terrible thing, right? So when you delete, you can't reuse it. You keep using a new one, right? So that is why we often use auto number, right? We don't reuse existing values. Right. D. OID value may not be visible to the external user. Yes, often it's invisible because it's machine generated. So often OID is auto number. Okay. Surrogated key in relational terminology. OID is used to create and manage inter-object references. Yes, your OID or the primary key is the reference foreign key in relationships, right? Your OID is like primary key, and your primary key will be referred by other tables as reference foreign keys. Yes, I'll go for B, D, and E. B, D, and E. Which of the following statements are true regarding student relation? Name, registration number, degree, year. The attribute set name is a key of the student relation. Set attribute set name is the key. Do we have the unique values at least? Pereira, Silva, Jananath. But this is not a very good one for the at key, right? So the key must be something like machine generated, right? So I don't think this is a good candidate for key because there can be two people with same name, right? Anyway, no, I'll keep it open for this time being because identically your key must be surrogated value, right, man? Object ID. Right, what about B? Attribute set registration number. That can be a good one for key if you need, but better to use something like surrogated key. Attribute set registration number is a minimal super key of student relation. Minimal super key. Minimal super key is basically primary key. Okay. Minimal super key means a candidate key. Okay. I think this is a possible candidate key because this is unique, right? But ideally we go for, but this doesn't say whether it's object database, right? It just says table, right? Yeah, because it just say relation. Yeah, it's a minimal super key. Okay, oh, it's a candidate key. I'll take it. Okay, I'll take it. C. The attribute set registration number, name, degree. Registration number, name, degree, all three. Is a super key. Yes, it's a super key because it contains the possible candidate key also and some additional things that is called super key. This is semester 2 database, but not the primary key. Yeah, this is not the primary key because this is not minimal. So this is a super key, but not the minimal. Minimal super key is a candidate key, but this is not a minimal because there are additional things. Yes, yeah, it's a super key, but not a primary key. Actually, this is semester 2 type question. Okay. D. The attribute set registration number, name, degree is a super key. Yes. Also the primary key. No, it's not primary. Attribute set registration number, name is minimal super key. No, because name is not required. I'll go for B and C. B and C. Yes, it's B and C. 7. What is the number of blocks needed for the file with 1000 records? Right, 1000 records. Place in a disk with 512 block. 512 blocks. Assume one record is 64 byte. Typical question. So what is block factor? Number of records per block, that is block size divided by size of a record 512 divided by 64. That is 8. 8 records per block. Okay. What is the number of blocks needed? 1000 records. So that means one block you can have 8, but you have 1000. 1000 divided by 8. So here you floor it, but here you seal it, right? Because partial to 12.8 block means 13 blocks, okay? Right, 1000 divided by 8. 1000 divided by 8. That is 125 blocks, right? Answer is A. Answer is A. 8. Which of the following indexing technique require the data file to be ordered? Right, ordered. Data file must be ordered. Hash you don't need because hash will give you the uh, block number, right? It's more random. Okay, so you don't need secondary index. Secondary index means your data file is not ordered on that, right? That is the meaning of secondary, right? So, of course, data file can be ordered or not ordered, right? But of course, all data file will be usually ordered based on primary key or cluster, other selected key, but it's not necessary for the secondary index because secondary index is a secondary way of accessing, right? Whether it's ordered or not, secondary index will work. Okay. Bitmap index, again, you don't need data file to be ordered, right? No, because you just go by your values. Okay. Primary index, cluster index, yes. Either you can have primary index or clustering index. That is based on your data file. Yes, definitely answer must be D and E. D and E. Ninth one. Consider the following relation in database that keeps track of vehicles and vehicle registration details for answering question 9 and 10. Chassis number, brand, model, manufacturer year. Okay. Registration number, chassis number must be foreign key, name, NIC, and registered year. So this should be the owner. Which of the following statements is true regarding constraint violations in vehicle and registration relations? Okay. Constraint violation. They have not mentioned any constraint. Maybe they are referring to foreign key and primary key. Okay. Right. Insert null into vehicle violate the referential integrity constraint. So this should be the first field. So that means it can't be chassis number, right? Chassis number can't be null because that's the primary key. That should be the primary key. Yes, underline. So, but that is not violation of referential integrity. That is a violation of entity integrity constraint. Let's see whether this violate referential integrity. So 1, 2, 3, 4. So this into vehicle. So here no foreign key, right? So vehicle table has no foreign key. Therefore, it cannot anyway violate referential integrity. Okay, because this is the vehicle table. So therefore, anyway, this is wrong because it violates, but not referential integrity. It violates entity integrity. So therefore, one is not answer. B. Insert SV05 blah 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 violates key constraint. Key constraint means entity integrity constraint. Is this already available? SV05. SV05 0345790. 0345790. Yes, it's already available. So therefore, it will violate entity integrity constraint. So key constraint means entity integrity constraint. Okay, so yes. So another name for entity integrity constraint is simply the key constraint, right? Primary key constraint. Because primary key must be unique and not null. I'll take B. C. Delete the vehicle tuple with chassis number SV blah 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 245. Violate entity integrity constraint. Right? Delete vehicle tuple 245. 245. Vehicle, this one. Do we have any record with this? SV24? SV24 0175. 0175 245. So that means if you delete this, there's a registration table, there's an entry which is not referring to a valid chassis number, right? Valid chassis number. Delete the vehicle tuple with chassis number violate the, but not entity integrity constraint. That will violate the referential integrity constraint, right? Read the question, right? Read the answers. Yes, it violates, but not the entity integrity constraint. It violates referential integrity constraint. So therefore, this is not answer. Okay. D. Update the chassis number of the registration tuple with registration number WPCBA. This to this violate the key constraint. Right? WPCBA. In registration table WPCBA 2034, right? Yes, so that is the first one, right? You change it to SV30. There's no SV30 value, but it must be valid value in the referential table. So therefore it is fine. It is unique. Okay. Sorry, this is about chassis number, right? Not registration number. Yeah, this one, chassis number. Okay, let's read it again. Yeah, chassis number is updated for registration number WPCBA, right? For this one, they change the chassis number, right? Currently it is SV30, but they change it to uh, SV30 0161 269. Yeah, 269. So that is fine, right? But that chassis number must be valid. Is it a valid chassis number? SV30 0169, SV30 0169, 0169, 269. But it is not a valid one. 269 is not valid, but it violates referential integrity. But this says it violates key constraint. Yes, it violates, but it violates the referential integrity, not entity or the key constraint. So therefore, I will not take that. Right? I will not take that. Last one. Update the chassis number of the vehicle tuple with chassis number vehicle tuple. Okay. What is the chassis number? SV05 0345790. What is that? SV05. SV05 is this one. 0345790. Yeah, 0345790 to this SV30 01267191 violate the primary key constraint and referential integrity. First, let's say whether we have a duplicate now. 0126791. Yes. So that means yeah, here. Uh, 0345790, that is this one. You change it to, right? You change it to SV30 01267191. Yes, so that violate, sorry, here, 790791, right? So this one. So it violates SV05, SV30. Yeah, so it violates entity integrity constraint, no key constraint. Key constraint is violated, okay? Primary key constraint and referential integrity constraint. So referential integrity constraint will be violated if this is already referred. SV050345. SV05. Yeah, it's already now this is invalid because you change this to this. So therefore it violates referential integrity as well. Yes, both. So that is correct, right? Because there will be a record in registration table which has no valid value in vehicle table. So I'll go for B and E. B and E. Yes, B and E. Okay. 10. Which of the following SQL statement specify the database constraints that the manufacturer year of a vehicle must be similar or prior to the registered year of the vehicle? Okay. Which of the following SQL statements specify database constraint? So they have created all assertions, right? Right. Let's first check create assertion. Create. So this is wrong. Create assertion, right? Create assertion. Create assertion. Year constraint. Okay. Year constraint. Uh, Year constraint. So now we have one answer wrong. Check. Okay. Check. 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 So usually you must check for the not exist anyway. All are checking for not exist. So far so good. Select all from. Okay. Specify that database constraint that the manufacturer year of a vehicle must be similar or prior to the registered year of the vehicle. That means manufacturer year must be same or earlier than registration year. Okay. Right. Vehicle V registration R, right? Vehicle V registration R where? Vehicle V registration R where? Vehicle V registration R where? V dot chassis number equal R dot chassis number and V dot manufacturing year must be greater than registration year. But what about the equal mark there? Right? Because it must be greater than or equal, right? Greater than or equal. But this is not exist, right? Not exist. Manufacturing year bigger than registration year. No, right? If it is not exist, it must be violation. So manufacturing year greater than registration year means so bigger means later, right? So that can't be. All right. So that is a violation, right? So your manufacturing year bigger than registration year means it's a violation. But it says similar or prior to the registration year, right? Similar or prior to. That means similar is not violating. Same is not violating. So this is not text, is violation. So it looks okay, right? Chassis number, V chassis number is our chassis number and V manufacturing year is greater than registration year. But, but this is not violating, right? Not text is manufacturing year. Yeah, this is violating, right? Manufacturing year bigger means violating. So this looks okay for me. Okay, let's look at the other one also. Others 10. Create assertion year, blah, blah, blah. Not text is select all from vehicle registration where chassis number is chassis number, correct? Anyway, that part is the same. V chassis number, R chassis number. There's E answer also, right? Okay. Okay, let's check the E also. Create year, sorry, it must be create assertion. So therefore E is not answer. Right, so C and manufacturing year is greater than registration year. So manufacturing year greater than registration year means you have manufactured after registration. Right, you have manufactured after registration. So that violates. But equal mark is not violation, right? Equal is okay. Right? Equal is okay. Equal is not a violation. But according to this, you need to check not to exist violation. But this is not a violation, right? So therefore, I will not go for C. Okay. D. Uh, manufacturing year is less than or equal to registered year. Manufactured year is less than or equal to registered year is valid, right? That means registration year is bigger. Ah, no, registration year is bigger is violation, right? Registration year must be smaller. But equality is not a violation. Equality is not a violation. But this says equality is also a violation. So therefore, I will not take this. So then it's A, right? A, right? What is the answer? 10th. Oh, C. Why is that? C. So is this a violation? Manufacturing year greater than or equal to registration year. But equally is not a violation, right? Here manufacturing year greater than. So this is because equal is not a violation, right? So therefore I don't agree with the examiner, right? For me it's A, but examiner it's C. Okay. For me it's A, but for examiner it is C. Let's ask from ChatGPT also. Right. For me, answer is A. Examiner answer is C. Oh, ChatGPT says both A and B is correct. Right. But anyway, my answer is also A. But ChatGPT says even B is correct. But ChatGPT doesn't agree with C. Okay. It doesn't agree with C. Why B has been taken? That is my next conclusion. Why ChatGPT says B is also correct. Anyway, ChatGPT has agreed with me, but right. Anyway, this is the same. Only this one we need to look at. Manufacturing year greater than registration year. If manufacturing year is greater than registration year, yes, right? Because equality mark equality is not a violation, right? Yes, equality is not a violation. You can see manufacturing year is greater than registration year. Then those are the same, right?
But create, there is no present assertion after create.
Yes. So this is create this assertion. That is why I took it out, right? Yes. So I think ChatGPT has missed that mainly because these are theory, right? These are theory. So therefore, anyway, then definitely answer must be A. Okay, definitely answer must be A, not E. Okay, not T. So let me mark that in the answer sheet. 10. I feel like it must be A. Right. Let me mark that because in the future there will be. Right. So then I need to open it in. Open with H. Right. 10. I will say A. Okay. I will not take C. Okay. I will not take C. But it's just my opinion. Okay. And ChatGPT confirms it. Okay. ChatGPT has confirmed that anyway. Right. So that is 10th one, debatable answer. But ChatGPT agree with my answer. Okay. Right. So that is 10th one. 11th one. Consider the below given schema for the marks relation in which students' marks for math, science, and history are recorded. Just give me 1 minute. Right. So the 11th one. Consider the given below given schema for the marks relation in which students' marks for math, science, and history are recorded. Which of the following SQL statements create the trigger student marks so that the total and average of specified marks are automatically inserted whenever a new record is inserted into marks? Okay, that's easy, right? Right. So whenever uh, it's one table, right? Yeah, just one table. A registration number, math, science, history. Then you need to calculate the total and average for that record. So the trigger is also triggering an update in the same table. No two tables, okay? No two tables. Uh, right, create student marks trigger before insert. Now it must be after insert. Okay, it must not be before. Before insert, can we do it? Yeah, right. Then it will be part of the insert statement, right? Yeah, yeah. So then it will be part of the insert statement, right? Trigger before insert on marks for each row set. Create trigger student marks before insert on marks for each row set. After insert, there's after insert one also, right? I prefer after insert. Okay. Uh, anyway, let's see. Create student marks trigger after insert. After inserts are there. Actually, I prefer after inserts, not before inserts. Create trigger student before insert on marks for each. Right. I feel like before or after doesn't matter, but I prefer after insert. Okay, because both should work. Okay, both should work. Yeah, but I prefer after insert. But let's see. Okay, let's see. But both should work as well, right? Because trigger the student marks so that the total and average of the specified marks are automatically inserted whenever new record is inserted into marks. Yeah, I feel like it doesn't matter. Okay, it doesn't matter because this is insert. Anyway, let's read. Marks dot total equal marks dot maths plus marks plus science marks dot history. Uh, so then what is the new? Where's the new value? But they never refer to new, right? New and old, maybe because it's insert. So there's no
So
old value.
when we use before, how can we use new?
Sorry?
If we use before, we can't use the new value, right?
No, new means the value to be inserted, value to be added, right?
So after the insertion, it can be contained inside the new, right?
No, new means not yet added to the table. The value to be inserted, fresh value that you are going to insert. That is what is my new. Remember in update, new means value to be updated. Old means current value. Okay. So here, if you want, you can use new, but because insert, you don't have all values, sometimes you can skip that also. But anyway, examiners cannot consider new all here, therefore I will just ignore it. Okay. So then average equal marks total divided by 3. So it looks all the answers are like that, right? Marks total is marks maths, marks science, marks history, marks average equal marks total. Can you see any difference between here? Here they say create student marks trigger, right? So therefore I will not take A. It must be create trigger, right? So here also create student mark trigger, right? So therefore I will not take D. Okay, right. So look, I now only I found that, right? So therefore A I don't need to consider, D I don't need to consider. Okay. Uh, right. So what about then others? B. Create trigger Suganmar, blah blah blah. But this looks okay for me so far. But what is the difference between B and C then? But only difference is before and after, right? Before and after. Uh, but for insert, can we have after value? No, you can't have after value, right? No, for insert, there's no after value, right? Before value. No, right? Actually, no before value, you have after value, right? Yeah. No before value, you have only after value. So
Yes, sir.
then I will go for C, not B. Okay. Because this says before. No, this is not after value. This is before the insertion. This is after this is complete different, right? This is new. I'm confusing with new and old, right? So this is before insertion. This is after insertion. Okay. But other than that, no change, right? No change. So if you forget about whether before or after, both are correct. Okay. What about T? Create trigger student before insert, set marks average, marks total divided by 3. But you calculate the total, you calculate average before total. That is little bit bad, right? If it execute in this sequence, uh, by this time still you don't have the total. Because total you calculate later, right? So therefore, I don't like that one, right? And if I forget about whether it's before or after, I will go for B and C both, right? I feel like any of these are okay for me, right? I don't mind whether it's before or after because it's an insert, okay? Uh, and this is just another calculation, right? But I feel like before is better because then you have all the data. After will make it little bit more less efficient because safely we can do this calculation, right? Before. This is not a tricky calculation. We all have the data. But if I forget it, I will go for B and C. B and C. Okay. Examiner has taken only B. So that means examiner thinks before is better. I think the examiner's argument is because you have the marks with you, why don't you just calculate those and just insert it rather than insert and then up. Basically, it will be update then, right? Insert and then update other two values, right? So I think because we have the values, these values, maybe we can just calculate those values and just do it. That means you, but without the record, can we do it? Right? Because usually triggers for inserts are after, because before there is no field, right? So therefore, I feel like C is better. C is better because let's ask ChatGPT. Okay, let's give this to ChatGPT because examiner's answer is uh, B, right? But I feel like C is the better one. Okay, I feel like C is the better one. Let's ask ChatGPT also because can we have before triggers for insert? Because record before inserting the record, how do you change it? Or maybe you have the values calculation without inserting. Okay, yeah, maybe, right? I don't know. Let's ask. Okay, better thing is ask ChatGPT also. Now I must, yeah, I'm running out of my uploads. Let me use the other one. What happened? The attachment. Right. So ChatGPT examiner says B, but I feel like C. Okay. So that is a issue. Oh, ChatGPT also says B, right? So ChatGPT says before. Let's see. Uh, Automatically compute total and average before the row is inserted. That means we have the values and then insert it. Yeah, I think, yeah, that is fine, right? So because we have the values with us before insertion, you do those things and then insert it straight away. Because if you do it after, so that means it's performance wise, it's not, it's less performing, right? Yeah, should be like that. Let's see what is the reason for C. It says cannot modify the columns after insert trigger. Too late to change total and average. Of course, then it will be another update statement, right? Yeah. So the idea is not do the insert and then update because this is same table. But if it is two tables, yes, right? So say you write trigger to this insert and then you write something up, some sort of other thing for another table. Then it can be after insert. But because this is the same table, right? The trigger is also for this table and this change is also for this table, this record. So therefore, yes, I think the best thing is, or the possible thing is before, right? After can be done. After this insertion is done, you take that and maybe update some other value in another table. Yes, then after. Okay. But I think, yes, this should be before, right? I agree with the examiner. Okay. Right, it's a tricky one, but because it's the same table, trigger is written to the this table and the change is also to the same record. Okay. Right. Next one. 12. Which of the following statement is are true for distributed database concepts? Right. Distributed database concepts. A. Naming transparency. Remember, transparency means you don't need to care. Okay. Naming transparency allows an object associated with name to be accessed without giving additional details such as location of the data. Yes, right? So naming transparency means you can just refer to it by name without giving any other thing, right? If it is employee table, employee table. You don't need to give anything else. Correct, right? B. Fault tolerance is one common approach in constructing a system that is available. Fault tolerance is one common
So
approach.
I think A is wrong
Why?
because it has to be location transparency if we hide the location.
Naming transparency allow an object associated with a name to be accessed without giving additional details such as name transparency means they have different names. Is it no right? There's nothing like no different names, right?
There
See,
has
huh?
different names.
If,
There
if
have different names.
if different names, how do you refer to them? That means the global schema. We just refer to the global schema name. Say site A, it's called DOB. Site B, it says date of birth. So then, is it name transparency? Okay, let's refer to the note. Uh, Name transparency. So I thought name transparency is a general concept. Let's refer to the note. Name transparency. Right. Location transparency means you don't need to refer to the location, right? Naming transparency, when a name is associated with an object, the object can be accessed without giving additional details, such as location of the data. You can see yes, right? When a name is associated with an object, the object can be accessed without giving additional details, such as location of the data. So that means different sites may use different names to the same data. Okay. But you can still refer to the global schema name. Say global schema, it say DOB, but different sites they may refer it as different names, but that is handled by the DBMs. You just refer to the common or the global schema name, right? So that is why they say something like location. At different locations, it may be different names, but you just refer to it as the global, according to the global scheme. Okay. Then of course the replication transparency, you don't need to aware of replications. You don't need to aware of fragmentation. You need to aware of any other design aspects, or you don't need to aware in which node your select statements are executed, right? Joins and so on. That is 100% determined by DBMS, right? I think uh, that is reasonable, right? That is reasonable. Okay. You don't need to worry about what is additional details in the location. Okay. Because you just referring to it to the global name. Okay. Global name. I Okay. Then anyway, let's see. Anyway, multiple answers are also possible. B. Fault tolerance is one common approach to constructing system that is available. Constructing a system that is available. Is it fault tolerance? Constructing, I think, and that is a different concept, right? Constructing. I'm not very sure about this point. Okay. Let's keep it open. Because fault tolerance is when one site is down, still you should survive with other sites, at least for some users. Okay. Anyway, let's see vertical scalability, right? Vertical scalability. That means you add more and more resources to a site rather than increase in number of sites. Vertical scalability expand the number of nodes. No, that is horizontal scalability, right? Horizontal scalability expand the capacity. No, that is vertical. So this is definitely wrong. It's other way. Okay. D. Design autonomy determines the extent to which each node can decide on sharing information with other nodes. It's nothing to do with sharing, right? It's all about you can design it in a different manner. Right? I don't think it's something to do with the sharing, right? Anyway, it's a little bit fussy for me. Partition tolerance, that is, you break it into partitions, right? Means at any time you can partition it without modifying. State that the system should have the capacity to continue operations while the network is partitioned. Yes, when you partition, you don't need to do any changes, right? Horizontal partitioning and so on. Okay, right. I'll say that. I'll take that. Okay, I'm confused about B and D, so therefore I'll go for A and E. Okay, A and E. Yes, so this examiner has not taken B and D. Okay. Anyway, it's confusing a little bit. Okay, I'm also not 100% sure because I have doubt. I just skip it. At 13. So this should be easy, right? Consider the following branch relation to company database. Which of the following fragmentation conditions could be used to construct the original branch relation? Branch ID, branch name, address, total employees, manage ID. A. This is a union. Total employees less than 100, total employees greater than 100. Then what happened to employees with 100? So therefore, I will not take it because this is not. So some of the records will be missing. Right. So this is less than 100. This is greater than 100. And this is equal 100. Okay. So that looks okay. Total employees less than 100. Total employees greater than 100. Total employees equal 100. I'll take that. C. It's a join. Common must be branch ID. Yes. Here you have the branch name and address. Here you have the total employees and manage ID plus the primary key. I'm happy with that. What about this? Here you don't have the primary key. So therefore you can't join. Without a common field, you can't join. Right? So therefore I will not take this. So this is union. So union is not going for 5. Okay, union is for sigma. For 5, you need to join, right? Inner join. I'll go for B and C, right? B and C. That is 30. Yes, B and C. Okay. 14. Consider the employee relation in company database, right? Employee database. Let E1, E2, and E3 are fragmentations of employee. Which of the following correctness rules of fragmentation are violated? Okay, right. So this is 5. Employee ID, name, basic salary. And then, sorry, first you do sigma greater than 16,000 and then you project. Okay. So here, first you do the 5 and then you do the sigma. Okay. And this is less than or equal to 60,000. This is greater than or equal to, that means the same record might go both ways. Okay. It's clear mess. Here we have only designation ID, high ID, department ID. Okay. So here the primary key is also missing because primary key is employee ID. So many issues. Okay. It's a real mess up. Right. Reconstruction is violated because E3 doesn't contain the primary key. Yes. Right. E3 doesn't contain the primary key, so therefore you can't join this properly. Right. I'll say yes. I'll say yes. B. Completeness is violated because E3 doesn't contain the primary key. Right. Completeness. Complete means you must get all the records. Right. E3 doesn't contain the primary key. Yes, it doesn't contain the primary key, but completeness is more related to union, right? All the records must be there. Right? All the records must be there. Right. So shall we double check these definition because I'm not 100% sure. Okay. What is completeness? I think completeness is related to sigma, right? All the records must be there. Shall we double check completeness? Disjoint. Where is that? Reconstruction. Reconstruction. Right. So we can see reconstruction of the original relation is done by taking the union of the fragments. It's related to union. Okay. Right. So reconstruction is more related to union, right? So we must get all the records. But what about then completeness? Sorry, completeness is related to union. Anyway, these words are very loosely used. Let's see, it must be after this. Replication, allocation, shredding. I think in your note, it is not directly mentioned. So shall we ask ChatGPT to give an explanation? Right. When it comes to in distributed databases, explain what are the three words used? Reconstruction, completeness, disjointness. Disjointness means usually the record must not be duplicated, right? Right. So it's us reconstruction, completeness, and disjointness. So reconstruction should be more related to joining, right? That is vertical fragmentation. Rebuild the original relation from its fragments without losing information. All right. So the reconstruction is done for horizontal fragmentation using union. vertical fragmentation using join. So that means we must be able to reconstruct and get the original data. Okay, right. So that is fine. Completeness. Data item of the original relation must appear in at least one fragment. Right. So that is more. Now reconstruction is after fragmentation, you try to gather the data. Right. So reconstruction is when you are try to read data, but completeness is when you try to write data. So all your record must be, you must be able to write it to at least one place. It must not be lost. Right. Every data item in the original relation must appear at least one fragment. Maybe I can add this to your note and update. Okay. So then disjointness, fragment should not overlap unnecessarily. So that means same data should not be but that you can do with purpose, right? For example, say a particular field which is not the foreign joining field, still you can put it both places, but then when you update, you need to update both places. Okay, so disjointness means you keep, say, a particular field only one place other than the joining field. And record wise also, if this is HR department employees, if the other one is finance department, so it must not be, some record must not be in both places. Okay. Anyway, I'll add this to your note and reshare the note as well, right? Okay. So now let's read it again. Reconstruction is violated because E3 doesn't contain primary key. E3 doesn't contain primary key. Yes, right? Then you can't reconstruct. Right? You can't reconstruct. That is correct. Completeness is violated because E3 doesn't contain primary key. E3. But that is reconstruction, right? Not the completeness. So completeness means you can't put it. Some records cannot be put it anywhere. I'll say no. Completeness would be fine as all tuples and columns are stored. But here I don't think all tuples and all records are stored, right, in this fragmentation. Okay. Because here we have greater than 60,000, less than 60,000. Here you do sigma and then phi, here you do, anyway, this is very confusing question, okay? But this is fine, right? Employee ID name basic salary, employee ID name basic salary. I think completeness is fine. The issue is disjointness because you can see 10,000, 60,000 employees are put it into both places. So, yeah, so D is definitely yes, violated. Completeness is violated as all tuples and columns are not stored. So if all tuples and columns are not stored, it's completeness issue. But here, do we have that issue? So other than 60,000, lesser than or equal to 60,000, bigger than or equal to 60,000. Here we have the employee ID name basic salary. Yes, here you don't have the employee ID, but that is still we have saved everything, but you can't join it. I'll say no. It's not the completeness, some other issue. It's a reconstruction issue. Okay. I feel completeness is fine. Okay. Uh, but the issue is disjointness, right? Disjointness and reconstruction issue, right? Reconstruction issue. For me, answer is ACD. Yes, ACD. You can see the examiner check the exact thing, right? So here the completeness is okay because you can see here greater than 60,000, lesser than 60,000. Of course, there's another issue that is disjointness, but completeness is not violated. And here we have set of fields, other fields are here. So completeness is not violated. But yes, disjointness is violated, right? Reconstruction is violated. You can put it, but you can't take it back. Right? It's like you can put it into partition, but you can't reconstruct. I think that's a very good example, right? Very good question. Maybe I will add it, okay, to your note. Maybe I can add this question also to that note. I hope it's clear, right? So when you need to look at only one aspect at a time, right? When you look at completeness, don't think about reconstruction or disjointness, right? When you look at reconstruction, of course, if completeness is not there, most of the time reconstruction may not be happen, right? Because if it is not complete, already some records are lost, then how do you get all the things? Right. I think if something is not complete, definitely it's not going to be reconstructed. But there can be situation is complete, right, but not reconstruct. In this case, it's complete but not reconstruct because here you don't have the common field. So you don't need the common field to make it complete, but you need the common field to make it reconstruct. Okay. So when you make it complete, sometimes there can be overlapping. That is not an issue for completeness, but it's an issue for disjointness. Okay. Right. So 15, 16, and these questions, how many questions are there? 23, 24, 25. Right. So we'll do these few questions about, okay, 10 questions and also latex uh, in a weekday class or maybe next Sunday class also. Fine, right? Okay. Maybe when, but not, probably not Monday, Tuesday, Wednesday, maybe Thursday evening session, right? Okay. So we'll do that. Right. We'll stop at this point because I have another class in the afternoon. Okay. Right. We'll stop at this point.
Thank you, sir.
Okay. You're welcome.